I'm doing Learners, Teachers and Pedagogies, and this is my assignment 2, my micro-teach. I'll be doing it for a Year 9 class using constructivist approach to teach structure of the Earth and tectonic plates and how that's affected the Earth. Okay, so good morning everyone, my name's Holly. Sorry, it's probably that. Okay, so we're going to be doing structure of the Earth today and the continental drift, how it's affected the Earth. Okay, so first up, who knows any of the layers of the Earth?
No, the core.
Come on, we're going to draw that on there. So grab it, come up here.
Draw.
We're going to grab a pen. I want you to label what you think is the core. And which core is that?
Oh. Inner core, maybe?
Yeah, you want to write it there? Very good. What? You said the core?
Inner.
There we go. Alright, does anyone know the next one?
Outside core.
Oh, very close. Inner.
Outer.
Very good. So we're going to draw that one too. Yep, come on up. Where reckon that next one is? Do you know the one?
I'm not 100% sure. Is that alright?
Starts with an M.
Oh, okay.
Oh, no, very close. There is an acro in there. Definitely. That's another M word. Anyone else know that?
Mantle.
Mantle. Do you want to come up and give that a try? There we go. You got the MA right. There we go. Ooh. Work for me. There you go. We've got the M.
Why is that working?
This
Oh,
is just
because I
actually your finger.
Is that how you spell?
Oh, way around it. Okay, we just use this. Wiped it all off. Keep going for a second.
We remember still.
That's okay.
Maybe 2 seconds. Anyone know the last one? It's at the edges of your crust.
Yes, crust.
Here we go.
Is
Do you
it?
want to draw it on? Yeah. You get the magic pen. Here's Earth. Do you know what layer it is? Oh,
She's
sorry.
getting it.
I thought you were landing again.
Oh.
Like, definitely the Earth. Okay, right, so we have all these layers. Does anyone know any of the proper names, the extra special names for any of them? Brenda?
Asthenosphere.
Lithosphere, definitely. Do you know what that is?
The red stuff.
It is in the red stuff. It's actually that if we divide it around like this top hot layer, which is more liquid, is the lithosphere. I have to ignore my writing, it's pretty bad. Okay, does anyone know what the other part is? To the mantle, the bottom part? No? It's called the mesosphere. Now, the difference between these two is that the asthenosphere is they're both really hot, but this one's a more liquid layer, so you actually have that magma in that layer. So a lot of volcanoes, all the magma comes up from in there when it cracks and through the Earth's crust. Now the Earth's crust, there's another name for that one. Anyone know that one? Starts with an L. It's called the lithosphere.
Oh, I was going to say
Yeah.
living sphere.
Living sphere. There isn't a word for the living stuff that is around the world. But do you know what that sphere is? Besides living sphere?
Biosphere?
Very good. Yeah. So that's called the biosphere. So yeah. So we have the inner core, the outer core, the mantle, the crust, or the lithosphere, and then you have the atmosphere as well, and also the hydrosphere, which is all water around the Earth as well. So rivers, lakes, oceans, lost in the hydrosphere. Okay, so it's pretty hot in this one in the middle, so that one gets about 7,000 degrees. In the outer core, it gets about 4,000 to 6,000, and in the mantle, it's about 500 degrees to about 2,000 degrees.
Excuse me, is the middle really hard?
It is actually. This is quite hard, and these layers are actually the more liquid layers, so it's more compressed right in the middle of the earth. Okay, so we have all these spheres, which is pretty cool, and what we're going to focus on today is actually the lithosphere, because we're going to look at tectonic plates. So we have tectonic plates all in the lithosphere, which is pretty much because they're less dense, but they're pretty hard, and they live on top of the asthenosphere, so it's all nice and magma, and they can actually float around a little bit. Now, when they do this, you can have different kinds of things happen. They can diverge, in which case they pull apart a bit, and they can cause pretty big ridges, and they can converge. Now, both of these two cause volcanoes, unfortunately. So they crack through and a bit of magma comes up, and you can also have earthquakes, which don't actually cause much of actual volcanoes or anything like that, or crushing, but it does, the actual plates move that way. Okay, so we've got that down. We'll go to the next part. So these are all the plates around the world. There's usually around 7 or 8 major ones, and as you can see them all down here, and at the edges of them you find lots of earthquakes, volcanoes, ridges, oceanic trenches, and whatnot, unfortunately. So luckily we live in the middle of Australia, so we're all good, mostly. Except for the occasional earthquake. Okay, so do you guys always think the Earth has looked like this? Any ideas of what you reckon it might have looked like in the past? Flat? Oh. Definitely was supposed to be flat a long time ago.
Were they all joined together?
Yeah.
Were they all joined together?
Yes, they were. Originally it was believed that it is. It isn't proven. It is a good theory though, because they have found a lot of different fossils of animals and plants that are actually on the same areas. I mean, if you can join them up, it's pretty cool. So I'll show you. So originally it was called Pangea. It was a big supercontinent, combined all the continents of the world. So as you can see here, you can see in the background what they reckon it would look like. And it was about 30 million years ago that they believe this happened. Yeah?
Was that when there was dinosaurs?
Oh, definitely. There was a few of them. But, yeah, this was definitely before. It was probably just around to a bit before then. But, yeah, so during this stage, it just breaks up, and a lot of them are actually found on, a lot of skeletons and fossils are actually found in a whole bunch of areas that have been common to all of them. Now, it eventually broke apart and it turned into Eurasia, and also Gondwanaland. So Australia was part of Gondwanaland, and also a couple of other continents around the world. So we had Antarctica, South America, Africa, India, and also parts of Southeast Asia and Australia. That was pretty cool. And eventually, as time went by, the tectonic plates actually moved and shifted a bit further away. So these guys here actually broke apart. They became what we have today.
Excuse me, miss, who named them?
Who named them?
Those funny names.
Oh.
It sounds like something out of Never-Ending Story.
It is quite a funny one. I can't remember offhand what the name was, but we'll definitely look that up. Hey, how about we make that homework for tonight? You guys can all have a look up and have a look and see if you can find a bit on this. Thank you, Jen. Okay, so now I'm going to do a little activity. I'm going to get you to off into groups of 2s or 3s, because there's 5 of you here today. And I've got little jigsaw pieces of the little continents around the world that would have made up Gondwanaland. So I'm going to see if you guys can piece it together from what you think. If you guys want to come together a bit, 2, 3 together, give it a try. They are handmade, so I do apologise. And hopefully they're all still there. They did go for a little wander today, but we found them. So you reckon, guys, you might want to put them in where you think they are on the planet at the moment and see if they can drift fairly closer. I'm not giving any hints.
Pretty sure it's triangles.
Oh.
Somewhere. Oh, yeah, like that.
Good. How about we have a look at what, according to other scientists, what they reckon it looks like. There we go. Who's close?
Oh, Indian whale.
Oh, I think we're pretty close. Oh, we got that against the mixed up. We were pretty close.
Oh,
Pretty
oh,
close.
yeah, oh, no whales.
That's it.
Oh, that's another god. Because I